suppose we have done the lab. And then what was implemented in the CPAS cloud service was based on an algorithm that construct mesh. This is the original paper. And basically the key things to handle is the mesh refinement part. From that paper, they gave idea that, look at the figure, the lower part of the figure has a coarser resolution, and the upper part of the figure has a finer resolution. These lines are actually connectivity. You may imagine that every point that these lines joins is actually the cell center of the cell, and then somewhere like this, having 6 lines joining together represents a hexagon having 6 neighbors. And the problem is the transition. And it has an algorithm that let people generate mesh with smooth transition. Like in this figure, if the transition is very steep, that in the way that there is only one layer as transition region, then the resulting transition will be too steep. And then look at the figure at the lowest row that tries to use more layers to construct the transition zone. Then the resulting is that after some optimization iterations, you will see that the topology changed smoothly from a coarse resolution region to a fine resolution region. So this is a basic idea, and the algorithm is implemented, and the software can be run on the cloud computing platform. And this is an example showing what it can do. So if you have already had this experience, but for this extreme case, you draw an absurd shape which has a concavity, then the result is that it can also generate a mesh. And here, the blue lines are the boundaries of the cell, and the gray line is actually the connectivity I have just shown on the paper. Now you will see that the gray lines are all triangles, and actually they have some properties, and I will go into detail later. And the result is that the transition of resolution goes quite smooth. And actually, for this algorithm, it has a characteristic that for the transition to be there will be pairs of pentagons and heptagons. That means pentagons is 五角形, heptagons 七角形, 七邊形. So if you plot some graph that I will also show later, you will see that pentagons are represented by purple color in this plot, and then heptagons are in this color, and between them is basically the transition zone. So in this example, there are already several layers of transition zone. So between where my mouse is pointing at, inside it has higher resolution. Outside, what we say delta x would be 2 times. The grid spacing will be 2 times that of inner. And then this is another transition. And then the grid spacing will be 4 times the inner one. And then 2 times more outside, it will be 8 times more the inner one. So if you make a plotting, usually the lines are too dense, but you can see that it is transiting for doubling the resolution here. and then another doubling of resolution here, and then another doubling of resolution here.